So we're given s of t. We're supposed to find the velocity and acceleration functions. So let me try to type it out here. Just got a mouse pad today. If you want the derivative of a function and it's a rational function, then you can use the power rule or the quotient rule. So the quotient rule is found by taking a derivative of the top function times the original bottom function, no derivative. Then you subtract that by original top function, no derivative, times the derivative of the bottom function. And then it's all over the original bottom function, not the derivative. Original bottom function squared. And that's, I think function notation usually goes like this. So that's the quotient rule. What we need are top function and bottom function to be listed out. Top function is just, it's in terms of t. Top function is just t. Bottom function is 1 plus t squared. And so the derivatives, derivative of the top function is nice and easy. It's just 1. And then the derivative of the bottom function is 2t. So we can plug those in. So we got 1 for the derivative of f of t times g of t. And then we have the original top function times the derivative of the bottom function. And then that's all over the original bottom function squared. So that's 1 plus t squared. So we can simplify that a little bit more. So that's 1 plus, so the derivative of s of t so that's going to be 1 plus t squared minus 2t squared. So that's 1 minus t squared in the numerator when you combine like terms. And then the bottom, oops, I missed my square here. In the bottom, that's 1 plus t squared squared. You can just leave it like that. That's the derivative of s of t. It's velocity. That's the velocity function. So that's what you would want to type in here. Acceleration is going to be the second derivative. So 2 apostrophes there to indicate the second derivative. So we want to do the same thing. We want to identify our f, our g. I think most textbooks use f and g, but you might see some stuff online that uses different letters for those functions. The derivative of f is going to be negative 2t. The derivative of t is going to be, actually, at this point in our course, I don't think we know the chain rule. So we have to expand this first. So this is 1 plus t squared in parentheses times 1 plus t squared, right? So if you write that out to the side and expand that, it's t to the 4th plus 2t squared plus 1. Yeah, and then down here, if you take the derivative term by term, and then now we can plug everything into the function, so into that, not function, into the formula for quotient rule. This is negative 2t times g, and then f of t in this case is 1 minus t squared times the derivative of g, and then it's all over original g squared, t to the 4th plus 2t squared plus 1. Let's see if I get everything. It's going to be a lot of, oh, no, here, I made a mistake. I plugged in 4t to the 3rd plus 4t in for g of t. That's t to the 4th plus 2t squared plus 1. Okay. And, okay, looks like I get everything else now. So we can simplify. This is just a brutal function, but accidentally clicked the new thing on Windows. Okay, so we can simplify. If you distribute the negative 2t and make it multiply to everything inside here. That's negative 2t to the fifth, subtracted by 4t to the third, subtracted by 2t. And then over here, I'm not going to use the minus sign yet. Multiply these two parentheses to each other, so that's going to be 4t to the third plus 4t minus 2. That's minus 4t to the fifth minus 4t to the third. That's all over. And you know, I missed the square on this one too. It's supposed to be, you know, the quotient rule is supposed to be g squared. I didn't put the square symbol at the end. Okay, and then that's all over t to the fourth plus 2t squared plus 1 squared. Getting closer. So we should combine like terms in the numerator. Do we need to? I mean, you can type all this in WebAssign. It might be hard to do though. There was like terms I could have combined here. 4t. No, man. With huge problems like this, there's lots of little mistakes that can be made. 1 times 4, that's right, plus 4t minus, I guess everything's right here. 4t to the third. Yeah, so this 4t to the third and minus 4t to the third, those can cancel each other out. Let's get rid of that. I'm distributing the minus sign to everything that's left over. That doesn't cancel out. So minus 4t, a negative 4t to the fifth makes positive 4t to the fifth. And a little more simplification that can be done in the numerator. It's way more algebra than calculus in this problem, huh? And then if we combine like terms, the highest power, negative 2t to the fifth, plus 4t to the fifth makes 2t to the fifth, minus next highest power is 4t to the third. Next highest power, combine those at 6t. And again, that's all over g squared. Okay. We could factor out a t, and then you can factor out a 2t from the numerator. I guess I'll do it. I'm out of room on my whiteboard here, so let's carry it over here. So factor out a 2t from the numerator, see if there's anything else we can do. 2t to the fourth minus 2t squared minus 3. Can that be factored? Two numbers multiplied by negative 3. The numerator can be factored. I don't think it has to be. We can just leave it there. Because look, t to the fourth minus 2t squared minus 3. You can factor that to be parentheses. Here, the numerator can be t to the second minus 3t to the second plus 1. Because that would multiply to be this. And then maybe you can factor the denominator. Two numbers yeah, you can factor the denominator. This is crazy. All right, let me do that. Get rid of that. Get rid of that. I'll show you what we can do to simplify it even more. Okay. So the numerator can be factored even more. T to the fourth minus 2t squared minus 3. That can be factored to be t squared minus 3, t squared plus 1. Because when you factor, you got to find two numbers that multiply to be the last number, but have to be the middle number. So negative 3 and 1. And then instead of just starting them off with like x to the first power, we just need t to the fourth. And then that only works because it's t squared in the middle term. And the denominator, this thing can be factored. We can put it back in our factored form, and I'll show you what we can do from there. is t squared plus 1 squared. That's what this factors to be. T squared, t to the fourth plus 2t squared plus 1. But then also being squared on the outside. So this is now going to be t to the fourth. Okay? This is t squared plus 1, like it was up here. T squared plus 1. And then if you're squaring it, a square on top of a square means it's going to be t to the fourth. And then the whole reason we did that is because this can cancel out with one of the ones in the denominator. So I think I'm done after this with the acceleration function. It's going to be 2t, t squared, minus 3. And then in the denominator, is going to be t squared plus 1 to the third. All right, it's as simple as I think I can make it. We'll stop there. That's just the acceleration function. Okay, and then we're supposed to determine the time intervals when the object is slowing down or speeding up. So we'll need the first derivative, and we'll need the second derivative for that. Because there's two possibilities. You're backing up or you're going forward, right? And so if you're backing up, your velocity should be negative. And if your velocity is negative and your acceleration is negative, that means the rate of change of your velocity is going down further. So a negative velocity and negative acceleration means you're backing up at a faster and faster rate. That's not slowing down, right? You're flooring it you're pushing harder on the accelerator when you get the car in reverse, if your velocity is negative and your acceleration is negative. Now, if your velocity is negative and your acceleration is positive, you're going faster back. Sorry, if your velocity is negative and your acceleration is positive, you're going backwards. But the rate of change of the slopes is positive. That means it's going towards the positive side. So you're slowing down. You're backing up, but you're slowing down. You got the car in reverse, but you're letting off the accelerator. So the big thing you want to look out for in these problems is when the velocity and the acceleration are opposite. If you want to find out when the object is slowing down, velocity and acceleration have opposite sign. Speeding up, velocity and acceleration have same signs. Look, if velocity is positive, that means you're going forward. If acceleration is positive, that means the slopes are increasing. So you're going faster in a forward direction. If your velocity is negative and your acceleration is negative, it means you're going backwards faster because the slopes are getting more negative. So that's the last part of this problem, is to do the algebra to find out where the velocity and acceleration are positive and negative. So here, get rid of all this monstrosity of work. Just get us the velocity and the acceleration in one place. And give myself some room to work. Okay, so we need to figure out where these equal 0. Okay, because they're going to cross 0. They're I can't think of the right math word. They're continuous. So that means they're going to have curves. They're going to, when they change direction, it's going to be a gradual change. And so if we find out all the places where they cross 0, we'll be able to identify where they're positive and where they're negative. So if we start with the first derivative, we want to find out where that crosses 0. Let's copy it down over here. So we want to set that equal to 0. So to solve that equation, you want to multiply both sides by 1 plus t squared, right? And that cancels it out down here. And that 0 times anything makes 0. So we're left with a much smaller equation. We've got 1 minus t squared equals 0. So to solve that equation, I'm going to add t squared to both sides to make it positive, to get myself a variable on one side, then take a square root of both sides. So t is going to be equal 1 or negative 1. But Since we're not going backwards in time, we're not going to consider it a negative value for time. So that means the derivative can only change directions at one place. Okay? Sorry about the mouse pad drawing. But at t equals 1, the first derivative has its only a chance of changing direction. So what you want to do is try out a value between 0 and 1, and then try out a value between 1 and positive infinity, because we've identified the only place where it can switch directions. So if you plug in 0.5 into the numerator and denominator, 0.5 squared plus 1, if you square that, that makes 1.5625 in the denominator. And then 1 minus 0.5, oh, it's 1 minus 0.5 squared in the numerator. Divide that by this. The basic idea, it doesn't really matter what number you get. The sign is the idea. Between 0 and 1, I got a positive sign. So that means the velocity is positive. We're going forward. And then let's try out an easier number. If you plug in 2 into the numerator, you're going to get a negative number, right? And if you plug 2 into the denominator, it doesn't matter what happens. A bunch of mumbo jumbo, it's definitely going to be positive. 1 minus 2 squared is going to be negative. So it's a negative divided by positive. So we're going to get a negative number. We're backing up between 1 and positive infinity. So this is for the first derivative. This is for s of t. We know all the places where it's positive and all the places where it's negative. For the second derivative, let's move that down here. Again, you want to set it equal to 0 and use the same approach. Find out all the places where it could potentially change from positive to negative. For setting that equal to 0, do the same thing. Multiply t squared plus 1 to the third power to both sides. Make that cancel out. So you're left with a simpler equation. You've got 2t times t squared minus 3 equals 0. It's already factored. We just have to set each factored piece equal to 0. We got 2t equals 0. We got t squared minus 3 equals 0. So if you solve both those separately, you're going to get t equals 0 and t equals the cubed root. Square root. That's a square, sorry. Square root of 3 here. And you can use symbols and WebAssign to type that. Okay, so those are the potential places where it could switch directions. So we got to do the same thing. We got to analyze both of those. And 0 actually is already a place that we consider, right? Because that's the starting point. And then we got square root of 3. So 1 is here. 1 is a potential switching point from our derivative, right? So that could be a place where it's changing from slowing down to speeding up because the derivative switches signs there. So we also want to consider 1 when we're looking at these. So you want a number between 1 and 1.73 to test to see what the sign is for the second derivative between those two numbers. So let's try 1.5. That's between 1 and the square root of 3. So if you plug 1.5 into the second derivative, the denominator is going to be positive no matter what, right? Because you're not doing any sort of subtraction down there. If you plug 1.5 into the numerator, you get a negative number. So negative divided by whatever that's going to be. It's going to be a positive. We just don't know what number. So negative divided by positive is going to make a negative. So we know the acceleration is negative between these two numbers. Actually, you know what? You don't need to test this because, yeah. So putting the 1 there isn't necessary. I just realized, but because look, between 0 and square root of 3, that's the only places where the second derivative could change direction. So if you plug in 1 in here, you get the same thing. You'll get a negative. So it's negative, negative, and then if you try a number bigger than square root of 3, like just plug something easy in, plug in like 2, then the numerator get 2 squared is 4, 4 minus 3 makes 1. It's a positive number, so everything to the right of the square root of 3 is going to be positive. Okay, so now we got that figured out, we can finally answer this question. Where is this thing slowing down? In interval notation, I'm thinking about where the velocity and the acceleration have different signs. Between 0 and 1, they have different signs, right? Velocity is positive, acceleration is negative. So 0 and 1, slowing down. And then from 1 to the square root of 3, they're both negative. So 1 to the square root of 3, speeding up. because they agree, right? What we said over here, they're speeding up. They have the same sign. And then they switch signs again. From square root of 3 to infinity, we have a positive for the acceleration and a negative for the velocity. So square root of 3 to infinity, they're opposite signs, so slowing down.